Hi, this is Mrs. LaBarbera. Today's topic is acceleration. The objectives for today is know definition of acceleration, understand the concepts of equilibrium and constant acceleration to be able to determine both magnitude and the direction of acceleration. Acceleration definition: how fast a velocity is changing. Acceleration equals to changing velocity over time. Since velocity has two parts, speed and direction, that means whenever you change your speed, you are accelerating, and whenever you change direction, you are accelerating. Equation: A equals to change velocity over time. How do we indicate change velocity? We use this triangle. It's called the delta, means change. Change velocity means the difference between velocity final minus initial. So VF is the final velocity, VI is the initial velocity. Pay attention, both final velocity and initial velocity are instantaneous velocities. They are not average velocities. So A equals delta V over T. We can substitute delta V with VF minus VI over T. Rearrange this equation so we can arrive to a second equation. VF equals VI plus AT. Both equations are in your reference table. Acceleration is a vector quantity. That means it has magnitude and a direction. The unit of acceleration is derived. It is represented by the combination of fundamental units. It is measured in velocity unit over the time unit. So velocity unit is meters per second over the time unit. When you combine these two, you can get meters per second squared. Another example of acceleration's unit is miles per hour squared. Anytime an object's velocity is changing, that means its speed change or its direction change, it has acceleration. In a car, there are three controls that can create acceleration. Number one is to speed up. You use gas pedal. To slow down, you use brake pedal. To change directions, you use steering wheel. Equilibrium. When an object's velocity is not changing, that means its speed is constant and its direction is constant, its acceleration is zero. When an object's acceleration is zero, we say the object is in equilibrium. When an object is in equilibrium, its acceleration is zero, that means its velocity is constant, no change in its speed or its direction. So what does equilibrium mean? It means acceleration equals zero and the velocity is constant. Constant acceleration versus changing acceleration. So constant acceleration is when an accelerating object will change its velocity by the same amount each second. Take a look, there are two tables. The table on the left indicate constant acceleration. How do we know? Because changing velocity is the same, 4, 4, 4, 4. So acceleration is constant because changing velocity is constant. The table on the right shows changing velocity is not constant, 1, 3, 1, 2. So the table on the right indicates acceleration is changing. Constant acceleration versus constant velocity. So constant acceleration means changing velocity is constant, in the same, has to be the same for each second. On the other hand, constant velocity means changing position or displacement has to be the same for each second. Take a look at the graph table on the left. This is the indication of constant acceleration because the change in velocity is constant. Now the table on the right indicate velocity is constant because it shows changing position is constant or displacement is constant. Whenever velocity is constant, acceleration equals to zero. Direction of an acceleration vector. The direction of the acceleration vector depends on whether the object is speeding up, slowing down, or changing direction. If the object is speeding up, then acceleration and velocity have the same direction. So if velocity is positive, acceleration and velocity are the same, acceleration has to be positive. If velocity is negative, since there has to be the same, so acceleration has to be negative. If an object is slowing down, then its acceleration is in the opposite direction as its velocity. So if velocity is positive, since they have to be opposite, acceleration has to be negative. Since velocity is negative and they have to be opposite, acceleration has to be positive. If an object is changing direction, then its acceleration is in the same direction as the final velocity. For example, if the object is traveling east and rebound to west, the acceleration has to be the same as the final. Final is west, so acceleration is west. So one thing is speeding up does not mean acceleration is positive. So speeding up only means acceleration and velocity are in the same direction. And similarly, slowing down does not mean acceleration is negative. Determine if acceleration is positive or negative for the following examples. A and B. Example A says it's speeding up. Speeding up, acceleration and velocity have the same direction. Since velocity is positive, acceleration has to be positive. This one is slowing down. So some of you may not agree with me. You may say, wait a second, -6 is bigger than -8. I learned that in math. Yes, you are correct. But in physics, this negative means direction. It does not mean magnitude. The magnitude is number only. This one is saying an object is traveling in the negative direction, could be west or to the left, and its speed is decreasing from 8 to 6 to 4 to 2. So you are slowing down. When you slow down, the acceleration and velocity are in the opposite direction. So since velocity is negative, acceleration has to be positive. Next two examples. You're slowing down in this case, opposite, so acceleration is negative. You are speeding up in the negative direction, you're speeding up, acceleration and velocity are the same. So velocity is negative, acceleration has to be negative. Categorize the following motion as being either positive or negative acceleration. So how do we figure out positive or negative? We see if it's speed up or slowing down. When it's speed up, it's the same, positive, positive. Slowing down, opposite, positive, negative. Speed up, same, negative, negative. Slowing down, opposite, negative means positive. Acceleration is positive. Let's do a couple of examples to figure out the magnitude of acceleration. Monty the monkey accelerated uniformly from rest to a velocity of 9 meters per second in a time span of 3 seconds. Calculate Monty's acceleration. So in physics, it's important to write down what is given. So what's given? Initial velocity is 0 meters per second because it's at rest. Final velocity is 9 meters per second. That's what's given to you. Another quantity given to you is the time, 3 seconds. How do you find acceleration? The next step is to write down the equation, then you substitute with number and units, then you solve, have units. Equation, Vf minus Vi over time. Substitute, Vf, 9 minus 0 meters per second over 3 seconds. So your answer with units, 3 meters per second squared. Next example, a child rides a bicycle at 15 meters per second, accelerates at a -3 meters per second squared for 4 seconds. What is the child's speed at end of 4-second interval? So write down what's given to you. Initial 15 meters per second. Final is the one you need to find out. Time interval 4 seconds, acceleration is -3 meters per second squared. Equation. To find a final speed, the equation for final speed is Vf equals Vi plus At. Substitute, and here is the answer. So that makes sense because acceleration is negative and your speed is positive. That means when they are opposite, you're slowing down. So your final answer should be less than your initial. Determine the magnitude of car's acceleration during the first 6 seconds, according to this graph. So now you have to figure out what's given in the graph. So the time is given to you. Another thing's given to you is the initial speed, final speed. Given initial is 0. You start from 0, final at 6 seconds. Your speed is 50 meters per second and time interval is 6 seconds. What is acceleration? Write down the equation, substitute, and solve. Equation, substitute, and solve. Next question. Automotive starts at rest and accelerate at 0.12 meters per second squared to a speed of 2.4 meters per second in 20 seconds. This motion could be best described as what? Initial 0, final 2.4, so we know speed is increasing. So velocity has to increase. It's not a constant velocity. So it can be C or D. Velocity has to increase. Now that's C. Is acceleration constant or increasing? So since velocity starts at rest and accelerate at 0.12 meters per second squared. So this one tells you acceleration is 0.12. 0.12 is constant. So the answer is C. Next question. The instant before the batter hits a 0.14 kilogram baseball, the velocity of the ball is 45 meters per second west. Remember when we talked about the convention directions, west is negative. The instant after the batter hits the ball's velocity is 35 meters east. That's positive. And the time the bat and ball are in contact for 1.0 times 10 to negative 2 seconds. Determine the magnitude and the direction of the acceleration. So write down what you know. What do you know? Initial is negative because it's west. Final is positive, east. And here's the time. What is the acceleration? Write down equation, substitute, and solve. Equation. Substitute 35 minus negative 45 divided by the time. So you will have 8,000 meters per second squared. Some of you, when you see this 8,000 right away, you think something is wrong. You did something wrong because it can't be this big. Yes, it can, because it's changing directions. Whenever an object changes directions, its acceleration is very, very big. So what is the magnitude and direction for this number? The magnitude is just this number, right? How big it is, 8,000 meters per second squared or per second per second. What's the direction? This is changing direction. So direction is the same as the final. Final is east, so the direction of acceleration is east. Another way to figure it out is the answer is positive. Positive is east. Next question. So I want you to stop, see if you can figure out this on your own. Then you can compare with the answers. So again, the magnitude is just a number. This negative means it's traveling to the west. Negative is the number. So that's it for today. See you next time.